Greetings! This is Brian Jepson here, and it's April 2017, and I've got Kim Arcand of many things, of Rhode Island, of the University of Rhode Island. And Kim, you told us a story about how you journeyed from ticks, studying ticks, to studying space. And that journey started at our shared alma mater, the University of Rhode Island. So tell me, how did you get started with ticks?
So I was really interested in infectious disease and parasites, and especially in New England, we all know that the ticks are they're all over the place, and we have to be really careful.
Yes.
But I realized after spending some time studying ticks that I didn't want to do that for like the rest of my life. So then I started moving towards computer science. And then eventually I was hired for NASA, so I started looking at
Whoa. Okay, so you started looking at computer science, and then you got hired by NASA.
Yep.
Now, was that like a 24-hour time span that happened in?
It was fast.
Really?
Yeah, it was maybe 2 years.
The 2 years.
The last year of my undergraduate degree at the University of Rhode Island, I started learning how to program and learning how to manipulate data, and I kind of continued my studies and was working on a project at the time for the Rhode Island Public Health Partnership.
Okay.
And that was a digital project. So my current director saw the materials that I was making for that program, and she liked them, and she stole me away.
Stole you away?
And happy ending.
Did that mean you went to did you go into space for your first job? Did you leave Rhode Island?
I did leave Rhode Island. I went all the way up to Massachusetts.
Oh my goodness.
Yeah, I know.
Wow.
I went to Cambridge, which was really far.
Yeah.
I never went into space because I get queasy on like a merry-go-round.
Yeah, I know the feeling.
No space for me.
Great. And so you've been working for NASA ever since?
Ever since, so about 19 years.
Wow.
Yeah.
Wow. Wow. And now you're the visualization lead for the Chandra X-ray Observatory. And why are X-rays important? We got a few questions about that.
X-rays are the best.
Why can't we just be happy with visible light?
So boring. All right, so we want to be able to look at things that are essentially really energetic. So Chandra looks at things like exploding stars, one of my personal favorites, areas around black holes, the hot gas between galaxies that occurs in galaxy clusters, and these things, they operate at really high energies. So we need X-ray telescopes to be able to see them, because otherwise it's not there to our
we wouldn't see anything.
puny, sad little human eyes.
So there's a hidden universe.
There is a hidden universe, and part of my job is to help reveal it.
And it's not just a telescope looking at a Messier object, for example.
Though we do look at Messier objects.
But it could be the X-rays could be useful when looking at. Does this come into play when you're, say, looking at the surface of another planet?
Yes.
Okay.
So, for example, Chandra has looked at most of the planets in our solar system, and we found that, for example, Jupiter has auroras, just like Earth does. So Chandra can study other planets as well. When you talk about exoplanets or planets beyond our solar system, Chandra's really useful for looking at the host star, because if the host star of those planets is too active and has too many X-ray flares, the chance of life on those other planets around it, as we understand it, 2 thumbs down.
So life doesn't like the X-rays.
X-rays are really not so hot for life. Can you imagine?
Yeah. So I was going to ask a question. I'm going to ask it anyways because it sounds like the answer may be no. But are there interesting, freaky X-ray things in our atmosphere that we don't see?
Freaky X-ray?
Like aurora. You mentioned Jupiter has aurora that you wouldn't see. I'm assuming you mean X-ray aurora.
Yeah, so X-ray images of the aurora, and yes, so we have actually observed Earth with Chandra, and we were actually able to observe X-rays from aurora.
Okay.
So we can see things like that, but our atmosphere has like all these superpowers. We couldn't hear without our atmosphere, we wouldn't be able to breathe without our atmosphere, and it also protects us from things like X-rays.
Yes.
So we're in a very good place to have our nice, cozy atmosphere protect us, because our life on this planet would not have been able to develop the way it did, or perhaps at all, if all that X-ray light, all that high energy light could have been constantly.
It may never it may never have started.
May never have. Who knows?
So that would have been bad.
Not if it was a lot of X-rays. Nope.
So you showed some Maya animations where you've taken the data, and I won't make you go over that process again, but I would like to know if somebody would like to learn more about the data that you're gathering in X-ray form and using to extrapolate into 3D images. Where do they go to find out about that?
If you go to the Chandra website, if you go to chandra.si.edu, we actually have a lot of material on our website for people to actually download and use themselves. We put up FITS data. FITS data essentially is a flexible image transport system that lets you look at the more raw elements of the image, so you can take it into a program and work on it yourself. And we also have all of the OBJ files and the STL files, the 3D printable files for our objects available on the Chandra website too.
So let's talk briefly about that. I know I said I wouldn't make you explain all that, but somehow you're able to take X-ray data and get us a 3D printable, 3D viewable version of something that's really far away. And I understand some of that involves the Doppler shift and also viewing an image over time, maybe? Okay, so I was paying attention.
So you were, so you get an A. So the key to being able to understand an image in 3 dimensions at this point in time is having a really rich data set. So the first object that I showed, Cassiopeia A, Chandra's been studying it on and off for almost 2 decades. And pretty much every other telescope that's ever been built has looked at that object at one time. So when you have a rich data set to work with, the possibilities are a lot bigger. There are other ways to work with 3D data sets, but it's a little bit trickier. You have to have your spectroscopic data. You have to understand the velocity of the material, whether it's moving away from you or towards you. There are a lot of different elements. It's a slow process for us at this point, but the collection of astronomical objects that we can understand in 3D is growing, and I'm very excited about that because it's a whole new way to understand your data.
Well, thank you for joining us on this cold, rainy night.
You're welcome.
And sharing this with Providence Geeks.